This is the Math 2 lesson summary video for the lesson entitled, Do You See What I See? In Lesson 6, Do You See What I See? The purpose of this lesson is to develop the idea of formal proof in geometry. We always start a formal proof with given assumptions, and we will need to use those given information to lead us to valid conclusions. So as we work through the lesson in the class, we did include some sentence frames in our notebook so that we could organize our thinking as we worked through the lesson. So please make sure you have these written down. We're going to use these. A few examples. To make the claim blank, I had to assume blank. So for each statement that we made in class, we did back it up with a reason that that statement was true. And then 2 vocabulary words you want to have in your notebook is the perpendicular bisector of a line segment, which is a segment that intersects the midpoint of the given segment, and it is perpendicular to a given segment. And then the property of an equilateral triangle and a rhombus, that all sides of these figures are congruent. So in Lesson 6, the first part showed us that diagram from the previous Lesson 5, where we then concluded that the sum of the angles in a triangle is 180 degrees. In number 1, 2, and 3, we were given a diagram, and we looked at the diagram and saw that we could say that it looks like that's an equilateral triangle. And the reason we can say this is that line segment AC and line segment AB are all radii of circle A. And if we look at line segment CB and line segment AB, we can see that those are radii of circle B. Therefore, what we concluded in class was that AC was congruent to AB, which was then congruent to BC. And the reason that we can say this is because they are radii, all are radii of congruent circles. So in this question, we had to assume that circle A was congruent to circle B. As we progress through this course, it will be very important that we are given information and that we use that given information to help us make a formal argument. So in number 4 and 5, we were given the same exact diagram, and we were asked to come up with several conjectures or educated guesses that we know are true based on the given. And in this case, we were given that circle A is congruent to circle B. So what we know then is that the radii of congruent circles should be congruent. So we know that AC will be congruent to AD, and we also know that BC will be congruent to BD. So in class, students came up with several conjectures. The first one that they came up with is that the quadrilateral is a rhombus. So in number 5, then we were asked to take our educated guess. In this case, the quadrilateral is a rhombus, and we were asked to justify how we determined that that was true. So we started off by what we call paragraph proof, because it did say write a paragraph, and we wrote a paragraph with every statement and the reason why we were saying that was true. So the first thing that we started off with, and I'm just going to come up back here and erase my diagram, is that segments AC, line segment AC, and line segment AD were congruent since they are both radii of circle A. Then we concluded that segment BC was congruent to segment BD because they are both radii of circle B. So since these two circles are congruent, which we were given up in our initial information, we can conclude that all 4 of those segments are congruent: line segment AC, line segment AD, line segment BC, and line segment BD. And I have marked that as such on my diagram with 1 tick mark each. So based on our information that we discussed in the last lesson, we know that if all 4 sides are congruent, we can then conclude in this case that it would be a rhombus. So the second conjecture we came up with was that the diagonals bisect each other. So again, we're given the same information. Circle A is congruent to circle B. So what we did was we already knew from the previous conjecture that ABC is ABCD is a rhombus, so we marked AC congruent to BC, AD congruent to BD. And then we said segment AB cuts the rhombus into two congruent triangles. And the reason we said that was based on our SSS congruence criteria from the previous lessons in this unit. So if we look at this diagram to the right, I'm just separated it from my original diagram. So we knew that AB would be congruent to itself because if we overlap triangle ACB would coincide very nicely onto triangle ADB. So we could see that AB was congruent to itself. And then line segment DC cuts the rhombus likewise. And DC, I didn't separate that from the diagram, but that would be this one here. And cuts the diagram into two congruent triangles for the same reason. These two cuts form four smaller triangles. So the four smaller triangles that we're looking at in this diagram, I'll just highlight them as we say them. Triangle ACP is congruent to triangle ADP, which is congruent to triangle BCP, which is over here, which is congruent to triangle BDP. So we have four congruent triangles. Since the triangles are congruent, we know that corresponding parts must be congruent. So we have, this is what we have so far, and then we know based on this that AP will be congruent to BP, and CP will be congruent to DP. Therefore, the diagonals of a rhombus bisect each other. So in number 7, we were asked to describe the sequence of steps that were used to construct the diagram on the right using the diagram at the left. So what we concluded in class is the sequence of steps was to draw line segment AB, locate the midpoint of line segment AB, and then construct a line perpendicular to AB through the midpoint of AB, which we've done at the earlier lessons in this unit. And then we picked any point on that line and we connected from that point, in this case C, to each of the endpoints, C to A and then C to B. So highlighting something that was on our vocabulary sheet is the fact that the points on the perpendicular bisector of a segment are equidistant from the endpoints of the segment. So Travis and Tehani were doing their math homework, and one of the questions asked them this question. So they went up to this diagram, and we know that, let's just call this line L. We know that line L is a perpendicular bisector. If this is a right angle, we also know that this on the right and the left would be a right angle because those two angles have to add to 180 degrees. So we saw that the length of C to, let's call this midpoint M, will be the same length because if we coincided those two triangles, they would overlap perfectly. And then what was already given was that AM was congruent to BM. So we could see here that these two triangles would be congruent by the side angle side congruence criteria, and therefore we can then conclude that AC would be congruent to BC because all corresponding parts in triangles must be congruent. So in 8, we just formalized our thinking into what looks like a two-column proof, which I'm going to show you in a moment. But we were trying to prove that line segment AC was congruent to line segment BC. And we first had to prove that triangle AMC was congruent to triangle BMC. And if we know that both triangles contain a right angle, then we can say that angle CMA and angle CMB are right angles. And if we know that the perpendicular bisector cuts segment AB into two congruent segments, then we can conclude or say that AM, line segment AM, is congruent to line segment BM. So we're trying to figure out the statement for each reason. So the next statement was that the segment from C to the midpoint of segment AB is the side of both triangles. So we can say that CM is congruent to itself. And then which triangles are congruent by SAS? That would be triangle AMC would be congruent to triangle BMC. And then we know, since the triangles are congruent, we can conclude that AC will be congruent to line segment BC because they are corresponding parts. So we have just proven from our vocabulary, we have proven that the points on the perpendicular bisector of a segment are equidistant from the endpoints of the segment. To organize that information, 9 asks us to put it into a 2-column proof, or to flow more easily. So this is an example of a 2-column proof for the question that Travis and Tehani were approached with. So all the information that we just wrote on the previous page on 8, this is organized into what we call a 2-column proof. As we progress through this course, these will be called our statements on the left and our reasons are on the right. And every statement and reason is numbered. So the statements on the left correspond with each reason on the right. If you need more help on the Ready, Set, Go homework for this task, please remember to check this Canvas student support site.